Good day once again. Today we are going to continue delivering our class regarding to operations research. So in our previous class, we have discussed on linear programming, the meaning of linear programming, the assumptions of linear programming, as well as formulations of linear programming. We have explained the procedures, the steps in which one has to follow before he formulates the linear programming. So today's lesson, we are going to see how we are going to start formulation of models regarding to linear programming activities. But before then, I would like to explain a little bit of some basic terms. Number one, that is the feasible solution. What is a feasible solution? Feasible solution is nothing but what? A specific value of the variables that satisfy all the constraints. So when we have a solution for any problem given, the feasible solution refers to the value of the basic variables that is going to satisfy all the constraints. The constraint, that means the activities that have been taking place or the operations that have been taking place for any given operation. Understand? Then the next thing is the feasible region. Feasible region is nothing but what? Set of feasible solutions. When you have a solution for any problem given, the feasible region, that means the coming together or set of feasible solutions. Then the last, that is the optimum solution. When we say an optimum solution, that is any feasible solution whose the objective functions and the value is greater. That means we are in the maximization problem, the feasible solution will be higher. Then in the minimization problem, the feasible solution will be the one which is very smallest. So this is just the definition of some basic terms. So now we are going to start solving examples on how are we going to formulate a models. So this is one example given. As you can see, the problem stated that a cruel seller plans to spend 2,000 naira on buying new grain sacks. The table below shows the cost and necessary weight for every sacks for 3 sacks A, V, and sack C she wants to buy. Then more of grain sacks A, then of B and C is needed, and there is only a single room in her house that can accommodate 200 kilograms of grains. So this is a problem given, and this is a table. This is grain sacks A, B, and C. It is being stated in the problem. We have 3 number of sacks. So here are they: grain sacks A, grain sacks B, as well as grain sacks B. The cost of the grain sacks is given as follows, as you can see. Then sacks A, it has 400. Sacks B, it has 500, as well as 600 refers to sack C. So this is the weight for every sack. Sack A is going to be weighted as 50 kilogram, and then sack B is being weighted as 60 kilogram. Likewise, sack C is weighted as 70 kilogram. So all what we are asked to do now is that we are going to formulate a linear programming model that is going to represent the problem. This is the only thing that we are going to see how we can do that. So we can do that by following the normal procedure on how to solve a problem of linear programming models. So first of all, what we are going to do is that we are going to have the solution, as you can see. solution. Then what we are going to do first, you see, in the formulation of linear programming, we stated that the first step we are going to follow is we have to identify the constraint. So how could we identify the constraint in this problem here? You see, we have the grain sacks, after the grain sacks, and then we have the cost of each one, and then we have the weight. So we are going to let X to be the grain of sacks A, and we are going to let the B, Y to be the grain sacks of B, likewise the C. So first of all, we have to say that let X be the grain sacks of A. And then let Y be the grain sack of B, and then let Z be the grain sack of C. So now we have fished out our constraint. So you see, we have let X to be the grain sacks of A, let Y to be the grain sacks of B, and we have let Z to be the grain sacks of C. Then what we are going to do now, we are going to put them into the problem as is being stated in the table. So therefore, then we take the cost of each grain sacks, 400x plus 500y, then plus 600z, then is less than or equals to 200, because the room that will accommodate the grains of sacks in our room is not going to accommodate something that is less than or greater than 200. So we have to make it to be as equals to, less than or equals to that 200 kilogram that our room can accommodate. So we are going to state that is less than or equals to 200. Then we finish off with the first segment. Then the next segment, then we are going to add the weight for each of the grains. Then we have to say that 50x plus 60y plus 70z is less than or equals to 200 again. So therefore, so I hope this will be clear. So what we take is that here is the total cost of every grain of the sacks. Sacks A, that is 400x, because we let X to be the grain sacks of A, and then plus 500y, because we let sacks B to be equals to Y. Then plus 600 of Z, because we have let the grain sacks of C to be equals to 600. Then all of them must be less than or equals to 200 kilogram that the room can accommodate. Then we have to add also the weight of each grain of the sacks. So we have to first of all start with the first one, that is grain sacks A, which is equals to 50x because we have let x to be of the what? Of the grain size A. Then 50x plus 60y, because we have let also the y to be represented as what? Size B also. Then plus 70 z, because we have let z to be equals to what? Grain size C. Also will be less than or equals to 200. Then what we are asked is for us to what? To formulate the linear programming. So therefore, all what is going to contain is going to be what? A must be greater than A must be greater than B plus C. So that's all. We have formulated our linear programming. All what we are going to be asked to do is that we are just going to formulate. We are not going to solve any problem, but rather we are just going to formulate. So here is how we are going to formulate. So A represents the number of sacks that is going to be accommodated in the room that can accommodate 200 kilograms. So A represents the entire number of sacks. So B plus C, that is the grain of the sacks. If we merge them together, must be what? The A must be greater than what? B plus C. First of all, that let H to be hard copy, and we are going to let P to be paper copy for easier clarification. So we have to first of all formulate number one scenario. So number one stated that 30 or more hard copies are going to be purchased. So therefore, number one, they say that 30 or more hard copies are going to be purchased. So, and we have let our heads to be what? To be equals to hard copy. So therefore, H is greater than or equals to 30. Then hard copy that is going to be purchased is going to be what? 30 or more. That is greater than or equals to what? 30 copies. We are finished with this. Then number two, the bookseller agrees to purchase more than 50 paperback copies. More than 50 paperback copies. So therefore, P, that is paper copy. Remember, we have let our P to be what? To be equals to paper copy. So therefore, P, that is paper copy, is greater than 50. We have also played with that. So the bookseller agrees to purchase more than 50 paper copies. So P is what? Is greater than 50 copies. Then number three scenario, which is what? At least 80 but fewer than 100 copies altogether. So therefore here, number three, that is H plus P, that is at least 80 but fewer than 100 copies altogether. Here, the bookseller is going to purchase at least 80 copies, but fewer than 100 copies altogether. That is in combination of both paper and hard copies that is going to be purchased, but they are going to be what? Fewer than 100, but he is requiring to purchase 80. So therefore, here in number three, we are going to say that hard copy plus what? Plus paper copy will be equals to what? Will be equals to at least 80. Then is either we say that is equals to 80, or we are going to say that what? Hard copy plus paper copy are what? Less than or equals to what? 80. Or hard copy plus paper copy will be what? Will be less than 100. So this is how we are going to formulate this problem. So as you can see, the bookseller agrees to purchase number 1, 30 or more hard copies. Here is what? H is greater than or equals to 30. Number 2 scenario stated that more than 50 paperback copies. That is, paperback is greater than what? 50 copies. Then in the third scenario, the bookseller agrees to purchase at least 80 but fewer than 100 copies altogether. That is, he is agreed to purchase both the paperback and the hard copy, about 80 of them, but fewer than 100. So therefore, we have 3 scenarios here. We can represent them as hard plus paper copy is equals to what? 80. Or hard plus paper copy is less than or equals to what? 80. Or hard plus paper is less than 100, because they state that but fewer than what? Fewer than 100. This is the reason why we stated that hard copy plus paper copy that is going to be purchased is going to be what? Less than 100. So now we have formulated this problem that is given. So I hope it is clear. Then we are having another example, but which I would like any one of you guys to go and try it as an exercise. So the example stated that it takes 2 meters of cloth to make a shirt and 3 meters to make a dress. So a tailor has 36 meters of cloth and need to make at least 6 of each. So you are asked what? To formulate a linear programming model to represent the problem. So thank you. This is the end of this class. So I would like to each and every one of you guys to go and try this example as an exercise. Then after you solve it, then you send it through my email address so that I can see the level of your understanding.